So, going along this line of geological issues or geological sciences, what would have been the origin of Earth's atmosphere? The best theory, again, we have is that as the nebular dust and gases accreted, or they became solid and formed the proto-Earth, which then solidified, had density stratification, and so on. There were still bombardments going on in the early solar system, and there was a process called outgassing. So the density stratification, cooling, and the stratification or the solidification itself was squeezing out the lighter material like gases and vapor and so on. So the outgassing occurred during the density stratification. Water vapor, carbon dioxide, hydrogen, and all the other gases would have been outgassed from the material that formed the Earth that we just looked at. So Earth's early atmosphere would have been very different from today. There are lots of issues in the paleoclimate you have to worry about, because the sun itself was 30% less luminous, so the energy coming in was less. Carbon dioxide was probably not the main greenhouse gas, it was probably methane. And prebiotic environment would have been post-biotic environment, which means if Earth formed at 4.6 billion years ago and life formed at 3.8, 3.9 billion years ago, you had almost a billion years or 900 million years without life, at least not on the surface. So oxygen composition would have also been different, because as we know now, atmospheric oxygen is heavily dependent on photosynthesis and so on. So the Earth's atmosphere would have been different as well. Origin of water, I think I mentioned briefly in another module early on. It's still, the debate still continues. Very recent work, for example, found some chondrites which formed during accretion, formation of the Earth itself, and found that actually enough water would have been there in the material that was forming Earth's structure. So the water would have been squeezed out from there itself. That means a lot of it wouldn't have to come from outside, because for a longest time there have been debates about whether lots of the comets from outside brought water to Earth. So by all theories we can think of right now based on data, water probably was outgassed from the material that was accreting and densifying and cooling and stratifying, outgassed into the atmosphere as water vapor, and then fell as rain on Earth and formed the oceans. The first permanent oceans, by all evidences, occurred 4 billion years ago, and the rain that we talk about here would have weathered a lot of the material that was still forming and still continues. So it is this rain combined with CO2 in the atmosphere forming carbonic acid and other things that are chemically able to weather the material from solid rocks and soils and so on, that would have washed all into the ocean. So salinity developed from dissolved rock elements. So early acidic rain would have dissolved more crustal minerals than today, but that's also a debate for the anthropogenic forcing of CO2. As we increase CO2, increase acidification, ocean obviously has an impact, but what is happening to the weathering rate? Why do you have to worry about it? Because if you are increasing weathering rate, it means you are putting more CO2 into the ocean, so it can act as a negative feedback, but those are very different time scale processes. We emit CO2 at a very fast rate by consuming fossil fuels, whereas the weathering rates are geologic time scale, so they happen on thousands of years time scale. Nonetheless, salinity has a very long residence time in the ocean. We haven't defined residence time, but you can imagine what it is intuitively. It is the amount of time a material will remain either in the atmosphere or in the ocean, and that is very long. It's a couple of 100 million years, which means for all practical purposes, salinity is a conserved variable in the ocean. So here is a little cartoonish sketch. Water vapor and other gases like CO2, sulfur and so on would have been emitted by all the volcanic activities and plate tectonic activities that were going on during the formation, cooling, density stratification of the Earth. So you would have a rain forming as the cooling was going on and filling up the ocean. You can see the land is dry in A and B, whereas you can see the blue colors on land and in the atmosphere. So rain would have put a lot of the water into the ocean. So as far as we know, oceans have been around for at least 4 billion years. New evidences keep emerging, and maybe time scales will change, but essentially at least 4 billion years. How did life originate on Earth? Is it because life has some perfect conditions compared to other planets? Well, that's not a question anymore, because it's fairly clear that there are other moons of Saturn and Jupiter, for example, and even Mars, and some parts of Moon may have water. So if water is an essential element, then water seems to be abundant in the solar system. But whatever we know, the other point that we don't know is whether life originated on Earth or it originated somewhere else and got thrown onto Earth. But nonetheless, Earth's earliest known life forms are 3.5 billion years old, or a little bit older. They are basically bacteria that are fossilized in ocean rocks. So it's not skeletal fossils, because there were no skeletal formations that far back. There were some form of basic bacteria that probably did what is called chemosynthesis. So they derived their energy from chemical reactions and not from photosynthesis. And these are the building blocks of life on early Earth from all the evidences we have. There is no direct evidence of early Earth's environment, so we have to just derive it based on other proxy evidences and do the best we can in understanding when and how life evolved. But this is a very interesting question that still has not been answered completely.